Introduce Sean Carter, who's the lead scientist for the National Climate Change and Wildlife Science Center, who will introduce our speakers.
Thanks, Danielle, and thanks to all who are joining us today. I'm pleased that we're partnering with the National Conservation Training Center to offer this series of webinars that highlight the work on climate change impacts that our center sponsors. Today's webinar is going to feature the GeoData portal, and it's going to be presented by Nate Booth and Adam Tarando. Nate Booth is the lead architect and program manager of the USGS's Center for Integrated Data Analytics in Middleton, Wisconsin. CETA partners with the USGS programs to provide innovative computing solutions for conducting interdisciplinary science across a growing array of massive environmental data collections. His team led the development of the GeoData portal. Dr. Tarando is a climate scientist and research coordinator in the North Carolina Cooperative Fish and Wildlife Research Unit in NC State. His research focuses on the impacts of climate change in ecosystems and agroecosystems and the complex human-environment relationships that drive these processes. So with that, I'll turn it over to Nate and Adam.
Okay, I think I have control. Hello, everybody. It's a good turnout today. Appreciate everybody taking time out and listening to the webinar. I'm going to present first, then I'm going to turn it over to my colleague, Adam, and then I'm going to provide some closing remarks, and then we're going to open it up for questions. So let's jump right into it. The agenda for the talk will be to give a bit of background on this project that was supported by the National Climate Change Wildlife Science Center program back in 2009, which has led to the GeoData portal. Adam will lead with a series of examples, and I'll follow on with a few additional examples. And then we'll provide a summary, and we'll get into some discussion. So back in 2009, we began this project, and the title of the project was the Development and Dissemination of High-Resolution National Climate Change Data Set, and it involved a partnership of PIs, including Jaime Collazo from North Carolina State, Lauren Hay from USGS's Modeling of Watershed Systems, Catherine Hayhoe from Texas Tech, myself, and Adam. And today we're going to focus on the second component of the project, which was the developing a system for disseminating these large downscaled climate data sets. And the motivation for the project, or at least this part of the project, was we wanted to make it easier for scientists and managers to discover what data exists in terms of these downscaled climate models, make it easier to access those large data and process those data for analysis. I've also listed here the 4 members of the GeoData portal development team, 2 of whom are here with me today. So the team includes Dave Blodgett, Tom Kanicki, Ivan Sufton, and Jordan Walker. So the initial design or conceptual model for this tool that we proposed back in 2009 is illustrated here. And the idea was that we had recognized that for supporting various kinds of models, such as hydrologic models, there's a need to access a variety of data sets, including downscaled climate, but also additional landscape data as well. And we recognized that folks were spending a lot of time accessing these data and reprocessing these data, oftentimes in similar ways, somewhat duplicatively. So we wanted to devise a system to simplify this process and provide some consistency for preparing all these data for analyses. And so this is what we started with, and this is what we've moved towards with the GeoData portal. So before the GeoData portal, this is how it sort of worked, and this may resonate with some of you, and it's probably the way it still works for quite a few folks in the community. But oftentimes when you wanted access to a large downscaled climate model, you made a phone call. You maybe, if you were lucky, you were able to access something like this, which was a large terabyte hard drive. They'd put it in the mail truck, deliver it to your office, and you'd work on it in a GIS and other software to prepare it for what you really want to do, which is to run it into a model or a series of coupled models. And then, like I mentioned before, this frequently was revisited one project to the next. And so what we've intended to do with the Geodata portal is to short-circuit a lot of that processing and make it easier to access these various large data sets using the internet as the mechanism for connecting all these various data resources with scientists. And so we'll get into these examples later in the presentation, but in addition to accessing climate data and summarizing climate data for geographic units like watersheds, which is shown in the lower right here, the Geodata portal can now also be used for real-time weather, such as the NOAA's NextRed indicated rainfall data set, and also can be used for landscape variables like the National Land Cover data set. And so those of us that work in the informatics field have been moving towards this paradigm, which is nicely written about in this paper called the geoprocessing web. And the idea is to use, again, the internet as a mechanism for moving data around and providing sophisticated and powerful processing of data through a web interface or through the internet. And so this whole idea, this whole paradigm is quite popular in many places across the community, including a large initiative within the National Science Foundation called EarthCube. And this slide, which I borrowed from Cliff Jacobs, also shows several prominent journals that are talking about big data, the challenges of big data, and the approaches for dealing with these large data sets in support of geosciences. And so again, this is another example of what we're trying to help satisfy in this community with the Geodata portal. So the approach that we took was first to understand these common patterns of accessing large data and processing the data for analysis and modeling. We spent quite a bit of time understanding the various communities, both the folks that were generating these sorts of data sets and the folks that would be using these data sets. And the Geodata portal provides this translation between these very different communities, the atmospheric community and the geosciences community, hydrologic modelers, ecological modelers, etc. And so the Geodata portal serves as a broker between these communities. And in order for us to provide some sustainability to this design, what we did was we tried to respect the way that these various communities like to work with their data. So from a geoscience standpoint, they like GIS, we like GIS. From an atmospheric sciences standpoint, they are more familiar and comfortable with other types of tools and software. So the Geodata portal sits between those two communities. Another guiding principle was that we wanted to provide these capabilities, which we'll describe through examples, not just through one tool, but through a series of tools that we'll also describe. And then finally, we've spent a lot of time dealing with how to optimize this solution for dealing with large data sets over the internet. The tool is based on common standards. I'm not going to get into a lot of the details on this slide. It's mostly for reference. But we've put great attention towards using common standards, again, to provide some sustainability to the approach, as well as to have reusability between the various data sets and not have the tool focusing on one particular data set, but rather a whole suite of data sets that can provide interfaces according to some standard, in some standard way. A lot of that work, a lot of the standards development that has been evolving to support this sort of an approach has happened within the Open Geospatial Consortium, and that's where we spend a lot of our time. Okay, so now I'm going to move into just an animated demo of how one would interact with the Geodata portal to access climate information. So once you come to the website, which we'll provide at the end of the webinar, you first describe the area of interest that you have. It could be anything from one to a series of watersheds. It could be a national wildlife refuge. It could be a political boundary, a state or a county. Any arbitrary area across the landscape that you want to summarize geographic or climate information to. So what we've done is provided a GIS file that describes the Upper Flint watershed here in the southeast part of the U.S., south of Atlanta. Second step is to come into the catalog that is behind the Geodata portal to identify the various data sets that are accessible. So we've spent time with a variety of atmospheric scientists in making linkages to their data holdings within the Geodata portal, and some of those are shown here. Once you select a data set of interest, you can see a full metadata record that can describe the methods that they used, as well as the variables that are accessible, as well as, importantly, proper accreditation to the authors of the data set. Once you choose your data set, you provide some configuration to how you want to process that data, as well as a time frame or a time range. And then oftentimes, not surprisingly, the processing will take a few minutes to even an hour or so. So you can specify your email, submit it, and then once the processing is done, you get an email response that echoes back the processing steps that you put in your recipe, as well as a link to the file to download. Okay, so that's quickly how one would operate the Geodata portal, and now we're going to jump into a series of examples which will hopefully make this much more interesting and real for how this can provide value to your science or your other analyses. Okay, I'm going to switch it. Can you switch it over to Adam, please?
Yes.
Okay, thanks, Nate. And so, yeah, we're going to pick it up with a couple of examples that people have scientists have been working on when they've been using the data portal. So, like Nate says, you know, from a scientist perspective, when you're doing global change research or climate change research, there's lots of data and lots of models, and so the question is, how can you spend less time dealing with individual data sets or individual modeling products and more time getting to your analysis and doing some science? So yeah, this is pretty evident when you can see that there's the CMIP3 archive, which has all the GCMs from the last IPCC assessment. So you can spend lots of time searching through here to get the proper model run and the proper variable. There's meteorological observations you can get from different websites. There's the Climate Wizard, which has visualization tools. That has another downscale website. There's also dynamically downscale projects such as NARCAP, where you can also retrieve data. And then there's local or regional projects, such as with the La Florida project sponsored by USGS at Florida State. So then finally, you know, even USGS in-house, we have our own dynamically downscaled projections. So there's lots of data, again, lots of models, and it can be kind of confusing and a bit overwhelming to try to be able to spend your time getting these data and figuring out how to get it for not only the types of models and variables you need, but for the specific place that your analysis is for. So can we use the GDP to facilitate the research process and spend less time on these sorts of activities? So we have a couple of examples here. The first one is from Mike Oslin, Dr. Mike Oslin from the National Wetlands Research Center. And he was using the data portal to look at climate impacts on potential changes in the range of mangroves in the Gulf Coast and along the Atlantic seaboard. So the hypothesis is that winter climate is an important driver for the salt marsh mangrove forests in the southeastern U.S. We know that mangroves are very sensitive to minimum temperatures, and and then you have this division between mangrove and and more saltwater marsh type systems along the coast. So how might winter climate change impact where mangroves to be located in the future. And so then the answer that first thing we need to do is find some data to be able to address this question. And so we can go to the data portal, and first thing you can do is upload a shapefile for the area that you have. And it doesn't have to be a shapefile or an area that's specific to what the data portal already has. You can upload something that you're working with, and the data portal will have no idea, has never worked with before, but it'll still work here. So for instance, here we have these coastal polygon IDs, which is attributed to National Wetlands Inventory data. So once you've uploaded your study area, then again, as Nate was saying, you do your pick different attributes that you need to configure the data portal with. Then you can pick your climate variable. In this case, we're looking at a downscale data set that has projections of minimum daily temperature for the next century or for the 21st century. And then you submit it for processing, and you wait to get your email back. And then you get your email saying everything's all ready. And then you have your data, and you're ready to go. And you get a nice table output. Could be NetCDF file format if you're familiar with that, which is pretty common in the climate community, or it could be a CSV file or a comma-separated file as well. And so here we see that this is that relationship that Mike has found, so he could help build this model with the data portal as well, since there's observed climatological data in there. And so you see here, this is the predicted percent of tidal saline wetlands that become dominated by mangroves as the minimum temperature increases. So this is what we have currently, 1970 to 2000. And then you see how that corresponds to the map of the mangrove presence today, pretty much limited to southeast coast of Louisiana, as well as around Florida. And then you can look at the projections based on those downscale climate projections that we obtain from the geodata portal. And so this is with a one scenario here. Let's see, I'm going to switch over to my little wand. So this is with a B1 emission scenario. So you can look at this for a lower emission scenario, so more of a climate stabilization type scenario. And the colors here correspond to the predicted percentage of each polygon that is dominated by mangroves. And versus a higher emission scenario, this is the A2 emission scenario, and you see the change in the difference in projected areas of mangrove dominance. So another example, and again, this is from Mike Osland, is we want to look at, say, how does precipitation affect the coastal wetland occurrence along the gradient on the western coast of the Gulf of Mexico. And so we see here, so starting out, we have some idea of how the system might behave. In this case, that precipitation has a big impact on the type of wetland that you would see along the coast. So you get a change in the ratio between unvegetated and vegetated wetlands in Texas. And so the question is, how could this change? And the objective here is to use precipitation and the coastal wetland occurrence data to develop some kind of model of abundance of these types of wetlands along the coast. So we already have the coastal wetland data, and so where can you get the climate data for your observations and your projections? And again, you use the data portal, and you can get your past climate data. In this case, we're looking at precipitation. And you see the time step here. This is daily data. And you have it for these individual grid IDs. And then you can develop your model. So you have your tidal percentage of tidal saline wetlands that are dominated by unvegetated, and you look at the relationship between that and precipitation. So hopefully really improving your ability, because you're taking out all of that time devoting to getting of sometimes terabytes worth of data, and then manually slicing and dicing that data set up to get it into both the format and in the area that you need. Okay, so then the final example I'm going to show you is another aspect of the data portal that we've been working on, and it's called right now we call it the Derivative Climate Portal. And this has been with a user group with myself and some other folks in the Fish and Wildlife Service, or the LCCs, and in the USGS and NOAA as well. So the idea behind looking at this derivative portal is we wanted to look at climate indices, because we realized that lots of times if you get a climate projection of, say, mean temperature change in over 70 to 100 years, it's really hard to link that to the biology or the ecology. You know, animals or plants or organisms aren't necessarily going to respond to, you know, if the mean temperature changes from 60 degrees Fahrenheit to 65 degrees Fahrenheit. Well, what does that mean exactly? But you might be able to find in the literature that there is different thresholds or indices for a particular species that are very important. And so can we speed up this process through the data portal and be able to calculate some of these indices on the fly and then access those? And so here's the website. We'll go over this again, but this is, this is a little bit separate from the data portal, but the same project. So it's the Derived Downscale Climate Projection Portal. And this is what it looks like. And so I'm just going to step through it here and show you some of the capabilities. We're not really focusing so particularly on the specific downscale data set for this, because hopefully eventually we'd like to expand this and have be able to use lots of different climate data sets. But just to see how it works so far. So the first step here is you have this interface, and to get rid of all the junk, like all the junk in the website above and below the picture, you click this little button here and that gets rid of that. But the first step is to pick the index you want. Right now we have a set of pre-calculated ones. It'd be nice, we would hope to be able to expand these as time goes on. But you pick what you want to look at, and I'm going to pick days with observed and projected days where the maximum temperature was above some threshold. Then you pick your threshold. So for the days above max temperature, right now there's 3 thresholds that have been pre-calculated. But again, in the future, we'd like to be able to do this on the fly, where the scientist or manager can put in their threshold, whether that's like 88 degrees or 102 or 70 degrees, whatever makes sense for that species that they're looking at. Then you're going to choose your emission scenario, and these are all the emission scenarios that were used in the last IPCC assessment: carbon dioxide, other greenhouse gas emissions. And they go basically from highest scenario of emissions at A1FI down to the lowest, which is B1. And then you can pick, what do you want to look at for the map? Do you want to look at the mean of all the models, or do you want to look at an individual climate model? So I'm going to pick the ensemble here. And then you're going to pick your time period that you want to look at as well. Here, since we're looking at a map, we really wanted to look at the average over a time period. So we pick 30-year averages, so you can pick which period you want to focus on. So once you made that decision, here I'm looking at just the A1FI emission scenario for the ensemble mean of all the models, and I'm looking at the past, so the hindcast projection from the climate models. And then you can look at the future as well. So here, now I've switched to the 21st century end of the 21st century projection, and you can see the change in the colors here. So the scale here is showing the projected number of days that are above 90 degrees Fahrenheit. And then you can easily, really quickly switch to a different emission scenario. So you can see here just the big difference between A1FI and B1. But you can also then you can change the how you want to depict the data. Instead of just looking at the raw projection, you can just click this button up here, and it'll show the change from the 1961 to 1990 baseline period. And so that may be a little more information, a little clearer information as to what's going on. So here you can see the A1FI projection, and you see large projected increases in warm days above what was seen in the past. And here is just summarizing that. So we have the A1FI projection, the B1 projection, the low emissions, and then we see the change from the B1 to the A1FI, and here it really becomes very stark, the difference in the two emission scenarios. So this is the emission scenario that we're really on track for right now. We're actually a little bit below the emissions in this one, and this is the very optimistic climate stabilized scenario. So then I'm going to show one more thing you can do with the derivative portal. I'm going to switch it up to now I'm looking at the frost days, or number of days where the minimum temperature was below 32 degrees Fahrenheit. This might be a little bit more of a ecologically meaningful variable for a lot of species. And so what I'm going to do now is, before I didn't do anything with this pull-down menu, but now I'm going to pick one of these areas of interest, and you see that there's these different options. So I'm going to pick LCC boundaries. That's a pretty useful one for the work I do. And so now what I'm going to do is I'm just going to click on an LCC that I want to look at. And so I'm going to pick this one. And then I'm showing you all the stuff that I cut out before. But once you do that, then it shows you, it'll calculate on the fly the time series. And so the average number of days where the minimum temperature was below freezing averaged over that LCC, wherever there are data. And so you see this is the decline in the number of frost days, not surprising, as the temperature gets warmer. And so just to zoom in here on what this is actually showing, so there's a lot of different things that you can manipulate with this time series here. You can change the emission scenario, you can show the range of the projections, and you can also download the data. So here, just an example of what this would look like. So the shading here is the individual model results, and then the dark line is the mean of all the models. So here I've turned on two emission scenarios, the high and the low emission scenarios, and you can see the difference. And here I've taken off the range, so uncheck the min and the max, and it just shows the median or the mean projection for all emission scenarios. And that makes it a little bit easier to compare across the emission scenarios then. And finally, I'm going to download the data, and I'm going to choose as a CSV file. And then you're ready to do some analysis. So here you have you have the times, you have the years, and then you have the output for each climate model for each emission scenario. And this is just looking at it in Excel, but I'm more of an R guy, so just a couple of commands in R, and you're ready to go with some analysis and hopefully make your research life a bit easier. So finally, just to show, just really quick, we're moving on into some additional global change data sets that we're going to be serving off of the data portal. So. And a lot of these are from the Southeast Regional Assessment Project, which I've been involved in, which is funded by USGS and the Southeast Climate Science Center, which are these websites down here. So we're going to be serving the urbanization projections, sea level rise projections, as well as landscape change, which is based on our vegetation dynamics work. But so the point is that the data portal is a really flexible format, and we're hoping that we can get a lot of these data sets, even aside from climate data. Some of these we've already put onto the data portal that will facilitate their research process. And with that, I think I'm going to hand it back over to Nate.
Okay, thanks, Al. I see I'm being made the presenter. Okay. Okay, so I'm just going to run through a few additional examples, and then we're going to open it up for questions. So another thing that we want to be able to support with the Geodata portal is to not only make it easier to access an individual model, but like what Adam showed in the derivative portal, access to various models and various emission scenarios, and then see how those various scenarios are impacting other sorts of models. And in this case, we're looking at how they affect a hydrologic model for the southeast. So this is just a quick 2 slides from Lauren Hay and Andy Bach from the USGS National Research Program and the Colorado Water Science Center, both in Colorado. And let me see, I think if I go big, okay, and then advance this, there we go. So what they've been doing is developing this approach that's going to look at a variety of downscale models, and again, a variety of scenarios within each, and then access those data for individual watersheds within their hydrologic model, run it through the hydrologic model, and then compare the output for the hydrologic model for each of those various runs to one another. And so Lauren and Andy have lots of preliminary graphics to show how this is coming out, and it's all work in progress. The main point that we wanted to make in this presentation is that this sort of thing really was not possible in any practical sense before the Geodata portal. To access any one of these data sets and to process those data into hydrologic units and to run them through a model would have taken months individually, and what we're able to do is this sort of important comparison now in a matter of weeks. So that's a great efficiency improvement. Second example, so I'm going to show a couple of slides here that are using some of the new urbanization model output that Adam just mentioned. So the Geodata portal for another hydrologic model project, watershed characterization and climate forcings, at least that part of the hydrologic modeling project, that again focusing on the Southeast Regional Assessment. So you've seen these sorts of screenshots before. This is the watershed of interest, and what we're going to do is we're going to access the National Land Cover data set. So the data set that's specified here is from the USGS National Map for land cover. We're going to access the PRISM climatology data set for this watershed, and we're going to access the urbanization model output that Adam just mentioned. And then from each of those runs, we can quickly look at how that watershed is characterized and then look at the forcing data for that watershed. So this is the breakdown of the National Land Cover data set categories for that watershed. Here's the time series of percent urbanization for that watershed from the urbanization model. And next, here is the PRISM data, the min, max, temperature, and precip for that time period for that watershed. This is another neat example. So this was more of just a demonstration, but it's a neat example of some of the unintended uses that the Geodata portal is now facilitating. So Rich Signal is a scientist from USGS Woods Hole, and with the drought this summer, he was curious just how much was precipitation down during the Dust Bowl of the 30s, and so he used the Geodata portal for this analysis. And the other thing that we wanted to show with this example was how you can interact with the Geodata portal not just through the website that we've been showing, but through a programmatic interface that's available through Python, which is becoming increasingly popular amongst toolboxes of scientists these days. So there's a nice Python library called IPython that helps you sort of tell this story. So here's an image from one of Ken Burns' documentaries showing the Dust Bowl. We're next going to open up a connection to the Geodata portal, and we're going to specify a particular county from northwestern Oklahoma that we're going to summarize historical climatology for. So, don't worry about the code here, but just mostly being shown to illustrate how you can access the Geodata portal using Python. So we're going to specify a time period. And then, of course, one of the nice advantages that you have with a scripting language with Python is access to all sorts of visualization libraries. And so, after running that command against the Geodata portal with the Python script, Rich was then able to develop this this time series graphic, which indeed shows this this major decrease in precipitation in the late 1930s. And then this is the last example, and this is an example from a scientist in the USGS Wisconsin Water Science Center, Steve Corsi, who's using the Geodata portal for accessing real-time NextRad indicated rainfall to support nearshore water quality models. And so in the Great Lakes, the beach water quality is impacted largely by tributaries, and we want to be able to characterize the flux from tributaries through models that take inputs including rainfall. And so this tool called NDAT, which is built on top of the Geodata portal, lets you specify your watershed for an area that's near your beach, and then can access real-time rainfall and summarize it and then bring it into your model. So that's another example that was unanticipated at the beginning of the project, but just another example of how with building this system on open standards, we're able to adapt it for other sorts of data besides just the long time series downscaled climate model output data. Okay, so we're just about 40 minutes in. We're going to do our summary, and then we're going to open it up for questions. So hopefully these examples have shown how the Geodata portal can provide a convenient way to access these large data sets. We're continuing to work to provide access to additional data and new data sets as they become available. And we've put the URL for the Geodata portal here on the bottom of the slide, and we encourage you to try it out and to provide feedback to us through the form on the website. And we'll try to follow up with you and incorporate any of those comments into future work as resources allow. So with that, I just thank everybody for their attention, and I think we're going to turn it over and open it up for questions.
Great. Thank you for a really great presentation, both Adam and Nate. So the way we usually do questions for our webinars is by having people press the raise hand icon on the main screen. It's in between the participant list and the chat box. It's a little white hand. If you press on that, you can raise your hand, and I'll call on you in the order that you raise your hand. And we did have one question typed into the chat box from Lucas Fortini. Lucas asks, any future plans to include Pacific and Caribbean island data into the data and or the climate index portals?
Adam, you want to take that one?
Sure. I mean, ideally, we definitely would like to. There are some more dynamic. I think they're more dynamically downscaled data sets available in the Caribbean, and I think actually I might punt back to you, Nate. But I mean, in general, I would love to get those in there. We have one project now where we're working on some statistically downscaled projections for Puerto Rico. But yeah, I think it would be great to add those in. Another thing that we should probably reiterate is that using these standards, you can, if you have any sort of OpenDAP data set, then you can use the data portal to access that. It doesn't have to be one of the 13 that are specifically listed there on the library of data sets.
Yeah, so just to follow up on that, during this presentation, we've purposely tried to keep it non-technical, but for making additional data available, provided those data sets, those models are available, we have we've gone through this several times now, and we have sort of a step-by-step set of instructions to make your data available and the sorts of standards that are needed for those kinds of data to be accessible within the Geodata portal. So we can follow up on that.
Okay, Esther Stroh, you can ask your question now. You'll have to press *6 to unmute your phone from the global mute.
Okay, well, first, I just want to say wow. But I do have a question, and I missed just the first couple of minutes, but I'm wondering, now I know that the operability won't be the same everywhere, but does the portal have some data available for other places besides North America, like Europe, specifically Northern Europe?
Adam, I'll probably defer to you on the various models that are accessible. We do have a global runoff model that's accessible through the portal, but that's, Adam, you want to help me out on any of the other climate models that might be accessible?
At this point, I think mostly it's been U.S. Data sets and Canada, but that's a good point that I would hope that we can get those up there, unless, I don't know if Dave's still sitting next to you, Nate, if he knows of anything else. But again, it's you can still use for the raw climate projections, or if you have like a European data set, if it's in that open depth framework, you can still access that through the data portal. So you can always use it to subset data that are out there that follow these open standards.
Okay, thanks.
Okay, to follow up on the first question, Teresa Valentine asks about data for Alaska, if that will be incorporated.
Right now there's one set of downscale projections for Alaska. I think they're provisional on there, but and those were done by Catherine Hayhoe, but those are up there. I'm not sure if I know we're talking about getting other downscale data sets on there as well, and I'm not sure if they've done Alaska yet, but there is one data set up there now, but it is still provisional data.
Okay, Jeff Stoner, you can ask your question now. You'll need to press *6 to unmute your phone.
Yeah, guys, that was a great presentation. Are you planning on follow-up presentations for other groups? This is the first I heard about this, and I'm sure there's a lot of people that would be very interested in this capability and tool.
Yeah, hey, Jeff. Certainly, yeah, just let me know what forums you think would be useful, and we'd be happy to put those on.
Okay, great. Thanks. Nice job, guys.
Thanks.
Okay, David, and I apologize if I mispronounced your last name, Sesbach, you can ask your question now. Press *6 to unmute your phone.
Hi, guys. Thanks a lot. That was a great presentation. This might be kind of a ignorant question because I really don't work with downscale data very much. But do you have any guidance in terms of working with that data that we get from the portal and elevation data? Is generally elevation included in the downscale data that we'll get?
No, that's a separate data set. Which I think there is a elevation data set that's already uploaded in the data portal, if I'm not mistaken. But yeah, was there? Can you?
I think the question might be more around correcting for elevation and the downscaling techniques, Adam.
Okay, yeah. For the most part, they already take into account. That's one of the first things that is usually done when you downscale, because that's such a important local effect on climate that the climate models, the raw climate models, usually won't be able to capture because it's just too coarse of a resolution. So that information is already embedded within the downscale projections. It's just more of a matter of what's the resolution of the downscaled climate projections, and because you don't want to go too fine a resolution because you just don't have the information to actually, you're not improving your accuracy anymore if you go too fine of a resolution. So there's typically some kind of compromise you have to make there in terms of getting it at a grain size that will be able to capture the local effects of climate change, but also still being at a scale where you have some confidence in your ability to model processes at that resolution. So that's almost like a topic for another day. But I know there's lots of guidance coming out about those things from the Department of Interior, and I think Forest Service also just came out with a guide on downscaling.
Okay, great, thanks.
Okay, I have a typed question from Joy Marburger. Joy asks, can you analyze multiple variables simultaneously for ecological predictions related to climate change?
Yeah, so whatever variables are available within the data set, you can access and summarize those simultaneously through the portal.
Okay, Nancy Green, you can ask your question now. You can press *6 to unmute your phone.
Hi, thanks for a terrific presentation, and thanks for just developing this. It looks like a great tool that will have a lot of applicability. I have a question about spatial scale, and I noticed in some of the slides you had predetermined spatial scales like LCC boundaries and other things like that. How much flexibility is there if people want to send you a GIS, file, or specify I want, just some irregular boundary, basically?
Sure. So this is Nate. Two-part answer. For the geodata portal, which gives you just the time series output from the model, from the downscaled climate model or other data sets, you currently can provide any arbitrary boundaries of any scale that you're interested in by uploading a common GIS file format called a shapefile format. For the derivative portal that Adam showed, which gives you access to indices, which is one step further in terms of processing, currently, yes, that product, that portal, is limited to a set of areas that are predefined. We'd be open to considering other sets of areas, and we're hoping that if resources allow, we can provide folks with the capability of summarizing those sorts of derivatives for any area of interest, but that's not available currently.
Okay, thanks. Really helpful.
Okay, we have a typed question from Cindy Swanson. Cindy asks, does the drop-down menu have the ability to look at land designation, in particular run models for wilderness areas?
I'm guessing that the drop-down menu she's talking about are the predefined areas of interest, and I guess it's a similar answer to the last question. If you have a GIS file that describes wilderness areas, you can upload it and you can summarize these data for those particular areas of interest.
Yeah, but again, for the derivative portal, it's only those predefined ones right now. But again, I would be interested in building more capability into that. But again, I guess Nate can confirm or deny this, but it's a trade-off on the processing time to do that.
Yeah, it's just something that we've heard from other folks. It's good to hear others have that particular interest, and it's just a matter of prioritizing that, again, as resources allow.
Okay, Phil Moorfield, you can ask your question now. You can press *6 to unmute your phone.
Thanks a lot. So just wanted to ask a couple of questions. So the first relates to sort of additional data sets. In this presentation, you mentioned NARCAP specifically. So I'm wondering if there are any plans to incorporate that particular data set in the future. I'm also thinking about like the CMIP5 files that are largely available now, and if you have any plans or for those data sets, if you could talk about that for a minute. And then also just wanted to ask when the derivative data portal is expected to be out of the sort of beta phase.
Nate, I'll let you handle those.
Okay, so one at a time. The NARCAP, we don't have access to it yet. We've heard that request. We'd like to develop access to it. It's as I recall, just for a lot of these questions, we're at a bit of a disadvantage because the fellow that that's really responsible for a lot of the architecture and has been working out access to new data sets. His name's Dave Blodgett, and he's on his honeymoon this week, so he's not here to answer these sorts of questions. So we're pinch hitting for him. But anyways, so NARCAP is not available now. It's something that we've heard, and we will work towards it. I think, as I recall, there were some data access restrictions that we were needing to deal with for that particular one. CMIP 5, we are working on with Lawrence Livermore, and you have to follow up in terms of ETA on that. I think it's going to be another few months at least. And then the last question was, what was the last question?
When does the derivative portal move out of beta?
Oh, right. So the derivative portal is in beta because the underlying downscaled climate model that it's based on is also provisional. So as Adam mentioned, we intend to provide those derivative portal capabilities with other climate models. So once the data set that's used currently is no longer provisional, or when we make the derivative portal available for models that are published, then the derivative portal will be out of beta. So that seems a bit confusing, I realize that, but that's the reason it's in that state currently.
Thanks.
Okay, Ed Laurent, you can ask your question now. Press *6 to unmute your phone.
Hi, it was a great presentation. I was wondering if you were using a grid standard for the integration of your different projections and for the export of the data, such as the military grid reference system.
If I understand your question, again, I'm at a bit of a disadvantage on this one. I'd ask you to follow up with Dave Blodgett, who we can provide contact information for. But the Geodata portal does have the ability to do projections. So if you upload a shapefile that's of any projection, the Geodata portal will convert it appropriately. And then also, we've spent a whole lot of time carefully being able to intersect things that are in a geographic reference system like our GIS files with atmospheric data, which is a whole different situation with the way they deal with spherical Earth and their grid. So that's about all I can say on that. And again, I'll just ask you to follow up.
Okay, we have a typed question from Ryan Bowles. He asks, can Adam perhaps comment on measures of error or skill that might be available?
Yeah, so right now it's just the raw output. I've talked with Dave Blodgett again on his honeymoon before, and we've discussed the possibility of adding those types of features on here. One thing would be operationalizing some different methods to include measures of uncertainty in these projections, such as like Bayesian model averaging or other methods that would get you at more probabilistic projections and would incorporate that uncertainty into these projections. Another thing that would be good on the derivative portal, I think, would be to add in the observed data sets onto there as well, and then that would be pretty easy to then calculate measures of bias off of that. So it's a good suggestion, and it's something that I think we're moving towards.
Okay, our next question's from Tom Kirkowski. He asks, is all your metadata standardized on the ISO standard? I believe the FGDC is encouraging agencies to migrate to this international standard. And then he has another question that asks, are you utilizing GeoNetwork as your metadata manager or server?
Sounds like one for you, Nate.
Yeah, so we are using GeoNetwork, and yes, we are basing all the metadata on ISO 19115, which is embraced by FGDC. So that's one of several standards that the Geodata Portal is based on, and we have a whole series of other presentations that deal with the architecture in more detail on these sorts of matters that we'd be happy to provide or share as time allows with folks like yourself. So again, feel free to follow up.
Okay, I have another typed question. If there are any more questions, just either type them in the chat box or press the little white raise hand icon. The next question is from Nicole Athern. She says, we're excited to see a Python API. Is there documentation on how to address data packages and models?
Yeah, so the Python stuff is pretty new. I feel like I'm ducking out of a lot of these questions, but I'd encourage you to follow up and we can put you in contact with the folks that are developing that. It is our intention to eventually turn those into Python packages with full documentation, but I don't have a concrete ETA on that.
Yeah, along those lines too, I've been really interested in being able to do something similar in, say, MATLAB or porting it over to R, which I think has a pretty good Python interface. So I'm really excited about that as well.
Okay, we have another typed question from Forrest Melton. Is there a process in place through which research teams can submit data for inclusion in the Geodata portal? Can the Geodata portal host new data sets, or does the Geodata portal require that the partner host the data on their own OpenDepth server?
Yeah, that's a very good question. So we've devised the system so that all of those options are possibilities. And obviously, for the Geodata portal to do the hosting and serving of the data, there are resource considerations. But if a team can make the data available over OpenDAP, and we would work with that team to configure it in an appropriate way so it works it performs well, then that's an approach that would work right away. And we need to go through a bit of a process to before we can reference that data set officially through the website, but certainly that's an option. Another option within USGS that we've recently been working on is with a project called ScienceBase. And what ScienceBase is all about is hosting project-level data. So the effort that we're underway with ScienceBase on is where a team can upload their project data into ScienceBase, and then there'll be a linkage to the Geodata portal where others can access and subset those project data using the Geodata portal. So those are three approaches that we're supporting at the moment.
Okay, Forrest followed up with that and asked who would be the best point of contact for proposing new data sets.
You can follow up with myself. I assume, this is Nate, you'll get my contact information after the webinar if you don't have it already.
And then another kind of communication question. Christopher Barnes asked if there's an email group that can be used to announce updates or developments to each of the two portals. Do you guys have an email list that you use for anything?
That's another very good suggestion. We don't do that. We participate quite frequently with an effort called the National Climate Prediction Platform, which does have such a capability, and if you're tuned into that, you likely will have seen that we've presented updates to that forum quite often. But that's a very good idea, and we'll take it under consideration for some sort of listserv or email outlet.
Great. Are there any more questions? Okay. I think that was a really great presentation, so thank you both Nate and Adam, and thank you everybody for all your great questions and for really actively participating. Sean, did you want to say anything before we sign out?
Just thank you to everyone. I thought it was tremendous, and I really appreciate the turnout and the questions. Everything was great.
All right, and this webinar will be recorded, or has been recorded, and it'll be edited and posted within probably the next week, by the end of next week. Everybody who registered for this webinar will get the link. And then I think that the Climate Science Center is also working on posting it somewhere so that people can access it easily. So that will be forthcoming in case you were not able to view the whole webinar or you know someone who wasn't. So thank you, everyone, and we'll see you again soon. Sean, do you want to tell them when the next webinar is going to be?
I don't have the date handy, but it'll be approximately the...
I do. I have it. So the next one for September is going to be September 27th, which is a Thursday, and it's at 3 p.m. All right. Thank you all. See you next time.